In this chapter 4 so far, we've talked a lot about relative max and relative min and absolute max and absolute min. And now in section 4.5, basically we use those ideas to in applications, in I guess what you'd call story problems. And the thing is, I don't know how realistic a lot of these problems are, but the ideas are ideas that you'll use in if you're if you're majoring in some area of a science area or an engineering area or mathematics. Okay, so anyway, so let's take a look at a few of these. I'll try to point out some ideas that will be common to all of these problems. So the first problem is just it's not very practical, but let's see what it talks about is it says how should two non-negative numbers be chosen so that their sum is 1 and the sum of their squares is as small as possible. All right, now probably some of you may know the answer to this already, but we'll work through it, and at least it'll allow us a format. What I'd like to do is I'd like to show you first the a picture of the situation here. All right, here what we have is we have a value x, all right, that we can adjust here, and basically on the vertical axis we're calculating x squared plus y squared, and y squared plus x squared is 1. Notice that x is 0.1 and y is 9, so they add up to 1, and they'll continue to do that. And notice as we change x, all right, notice that if we start here at 0, it will be at 1. The sum of the squares will be 0 squared plus 1 squared. But then as we increase the value of x, notice, all right, the sum of their squares decreases, okay, until we get to, and we should be able to see it here at about, I might not be able to monitor, till about 0.5, all right, and then it starts to increase. And I think that probably you're pretty well convinced that this minimum happens at 0.5, but let's show that that's the case here, all right? And so again, we have two non-negative numbers chosen so that their sum is 1 and that the sum of their squares is as small as possible. So we're going to have an expression that we'll want to minimize. So we'll let the numbers be x and y. Right, and we want to make the sum of their squares as small as possible. So here's the expression that we want to minimize. So x squared plus y squared. We want to make this as small as possible. And so there's one thing that you need to look for is there's going to be a quantity. There's going to be a quantity that you want to optimize. All right, optimize just usually means minimize in some instances and maximize in other instances. For example, if it were a profit, you'd want to maximize it. If it were a cost, you may want to minimize it. But anyway, so in this case, we want to optimize this quantity. We want to minimize this. Now, usually along with this, there's some other ideas, and the idea is there's going to be another, I'll call it a restriction or a constraint, as sometimes it's called. And the constraint in this case is that these numbers have to add up to 1. You see, this quantity depends on two different variables, x and y. And the thing is that minimizing a function of x and y, all right, is a concept for calculus 3. But this constraint, what it does is what it will allow us to do is it'll allow us to get rid of one of those variables. So we see that in this case y then is equal to 1 minus x. So we could rewrite this as x squared plus, instead of y squared, the quantity 1 minus x squared. Okay, and now we could call this a function. It's the same expression, same thing, but we want to minimize this. When we were minimizing functions in section 4.4, we always had an interval, and notice the numbers have to be non-negative. And so x has to be greater than or equal to 0. Okay, oops. X has to be greater than or equal to 0. And similarly, y has to be greater than or equal to 0. So the biggest x would be 1. If x were 1, y would be 0. If x got any bigger than 1, y would be negative. So x has to be between 0 and 1. All right, and that would be inclusive. So notice that what we can say here is another way of writing this is find the minimum value for f of x equals x squared plus 1 minus x, the quantity squared, on, well, x is on this closed and bounded interval from 0 to 1. So remember that then is when we have a continuous function, this is continuous. You'd see if we multiplied it all out and expanded it and combined like terms, we just have a polynomial. I'm not going to do that, but we could. And so that we'd have a continuous function on a closed and bounded interval. So remember that the possible places where we could have the minimum value were at, remember, the ends, so the left end, at the other end, the right end, or at a critical point in between. So now I have to take the derivative to find the critical points. This is, I guess, number 3 we called that. And so the derivative of x squared is 2x. And I'm not going to expand this out. What I'll do is I'll use a chain rule on it. This will give us some practice with the chain rule. So I'll have 2 times 1 minus x to the first power, then times the derivative of what's inside. What's inside? The derivative of what's inside? Well, the derivative of 1 is 0. Derivative of x is negative 1. So this would be minus 1. And so let's see. I'm going to simplify this. So this is going to be 2x, and then I'll have a negative 2 times all this. This is just raised to the first power, so negative 2 times 1, negative 2. And negative 2 times negative x is plus 2x. And so this would be 4x minus 2. And so the critical points are where this is either 0 or undefined. So let's set it equal to 0. And if we do that, we'd have x is equal to 2 over 4, 1/2. All right, and now what we could do, and I believe I've done this in the next page, is we could check the value at 0, at 1, and at 1/2. I guess I haven't done that, but let's take a look. Let's see, at x is equal to 0. All right, well, remember our function was x squared plus 1 minus x squared. So that would be, I'll write it up above here just so we remember it. So when x is equal to 0, this will be 0, plus 1 minus 0, that'll be 1 squared, and that's 1. When x is equal to 1, the other end, f of 1, will be 1 squared, plus 1 minus 1 squared, that would be 0, and that's 1. And when x is equal to 1/2, we'll have 1/2 squared, which is 1/4, plus 1 minus 1/2, which is 1/2 again, squared is 1/4, and this is going to be 2/4 or 1/2. So the minimum value is what we're looking at is right here. The minimum value, I'll write it out. Sorry about the dog. The minimum the minimum sum of squares is 1/2 when, and I'll give the two numbers x is equal to 1/2. And remember y, when we added y to x, we got 1, and y is equal to 1/2. Okay, again, sorry about the dog. And so that would be the answer to this problem, the solution to this problem.